Okay, today we're going to talk about how to graph quadratic functions that are written in standard form. And the standard form of quadratic function looks like that. F of x equal to ax squared plus bx plus c. Now yesterday we talked about the vertex form, and the vertex form of a quadratic function looks like this. Where the vertex is the point HK. Okay, so that's why it's called vertex form. Now in standard form we are given some information. In standard form, one thing we can find right away is the y-intercept, because if you think about it, if we plug 0 in for x, which is how you find the y-intercept, we would end up with 0 plus c, which is c. So that constant in the standard form gives us our y-intercept. Now, some other information we can find from standard form is the axis of symmetry, which is a vertical line right through the vertex. So the equation of the axis of symmetry, which is a vertical line, is x equals, and then it's the opposite of b over 2a. And we are going to use that a lot today to find that vertex. So then in order to find the y-coordinate of that vertex, you take that value and plug it back into the function. So we're going to graph these functions, and the first thing we're going to do is draw the xy axis. And in each case, we can find the y-intercept right away. The y-intercept in A is the point 0, 3. Now, to find where the vertex is located, we use that fact that the x-coordinate of the vertex, or the axis of symmetry, is the opposite of b over 2a. Well, in this function, b is 2 and a is 1. So 2 times 1 is 2. So the x-coordinate of our vertex is -1. So that means that our axis of symmetry comes right down here. So what that tells us is that our vertex is somewhere on that line. Now, to find out where, we're going to substitute -1 in for x into our original function. So y is equal to -1 squared plus 2 times 1 plus 3. So then -1 squared is 1, 2 times 1 is 2, plus 3. Sorry, 2 times -1. Got to be careful, make sure we're substituting. So this is -2. So this becomes -1 plus 3, which is 2. So our vertex is the point -1, 2. So our parabola looks like this. And it should open up since a is positive. And all that's left is labeling that y-intercept and giving the domain and range. The domain, once again, -infinity to infinity from left to right. And the range, bottom to top, we start at 2 and go up to infinity, is the range of that parabola. Now, with our next one, we have a y-intercept of -5, which I will put about there. And to find our vertex, again, we find A first, or I'm sorry, the x-coordinate first is the opposite of B, which is 4, over 2 times A. Well, now A is negative 1. So 2 times negative 1 is negative 2. So our x-coordinate of our vertex is 2. So the axis of symmetry is the line x equals 2. Now, to find the y-coordinate of that vertex, because the vertex is going to lie on this line somewhere, we plug 2 in for x. So then y is equal to the opposite of 2 squared plus 4 times 2, making sure of the sign again, and minus 5. So here we have negative 4 plus 8 minus 5. So we have 4 minus 5, which is negative 1. So our vertex is at the point 2, negative 1. And it will open down. The y-intercept once again was 0, negative 5. And again, what's left to find is the domain and range. The domain, left to right, is negative infinity to infinity. And the range is negative infinity to negative 1, with a bracket around that negative 1. Now, the next two examples get a little bit tougher because now A is something other than 1. So for both of these, I'm going to go ahead and draw the axes. So first of all, for C, I'm going to, picking up again, with this first one, the y-intercept is a point 0.07, so I'll put that point up here somewhere. And we can find that axis of symmetry by using that opposite of B over 2A. In this case, B is 20, and A is 2, so 2 times A will be 4. So the axis of symmetry is at x equals negative 5. So I'm going to go ahead and draw that in. There's our axis of symmetry, x equals negative 5. And I know that my vertex is going to be on that axis somewhere. To find that, we're going to substitute negative 5 in for x. So we're going to have 2 times negative 5 squared plus 20 times negative 5. Haha, I remembered the sign that time. Plus 7. So 2 times negative 5 squared is 25, times 2 is 50. 20 times negative 5 is negative 100, plus 7. So our vertex is at negative 43. So we're going to be down here at the point negative 5, negative 43. And our y-intercept is at 7. Now you'll notice in the directions I ask you only to label the vertex and the y-intercept. We're going to worry about finding those x-intercepts later in the unit. We can still fill in the domain, negative infinity to infinity, and the range starts at the bottom, negative 43 to infinity. So for D, get rid of these stray marks. So for D, the y-intercept is negative 5, so we'll put that about here. So to find that axis of symmetry, this is where we use the negative b over 2a. So b is 2. 2 times negative 2 is negative 4. So that becomes positive 1/2. So here's our axis of symmetry at x equals 1/2. So with this, we can find the y-coordinate of the vertex by taking 1/2 and plugging it in for x. We're going to have some fractions to work with, but that's okay. So we have negative 2 times 1/2 squared plus 2 times 1/2 minus 5. So 1/2 squared is 1/4 times negative 2 is negative 1/2 plus 1 minus 5. So we have negative 1/2, positive 1/2 minus 5 is negative 4 1/2. So we will be right here. That vertex point is the point 1/2. It'll turn out to be negative 4 1/2 is negative 9/2. And the y-intercept is the point 0, negative 5. And with the domain and range, the domain once again is negative infinity to infinity. And the range from bottom to top, be careful of the order, negative infinity to negative 9/2 with the bracket. And the last two, the last one in particular, will get pretty tricky with finding that y-coordinate of the vertex. But I know you guys can handle it. It's just fractions after all. So drawing the axes first. All right, so for the first one, the y-intercept is negative 2. So plug 0 in for all the x's. And that axis of symmetry is going to be x equals that opposite of b over 2a, opposite. B is 8. A is 2, so 2 times that is 4. So the axis of symmetry is at x equals negative 2. Okay? So we know the vertex is going to be on that line somewhere, and we're going to find that by plugging negative 2 in for x. So to find that, 2 squared is 4, negative 2 squared is 4, times 2 is 8, minus 16 minus 2, so we have negative 8 minus 2. So that's going to be down here at negative 10. So that is a point negative 2, negative 10. So one branch of the parabola goes that direction, the other one goes that direction, and the y-intercept is the point 0, negative 2. And for the domain and range, and again, later in the unit is when we'll focus on finding those x-intercepts, so don't worry about those for now. The domain is negative infinity to infinity, and the range is negative 10 to infinity. And finally, with f, the y-intercept is 6, so we'll put that about there. To find that axis of symmetry, this is going to get a little bit rough. This is the opposite of b, which is negative 4, over 2 times negative 3, which is negative 6. So since we have an odd number of negatives, our overall x value is going to be negative. And 4 over 6 reduces to 2/3. So our axis of symmetry is a vertical line, x equals negative 2/3. So to find the y coordinate of that vertex, we're going to plug negative 2/3 in for x. So we have negative 3 times 2/3 squared, negative 2/3 squared, minus 4 times negative 2/3 plus 6. So in this case, negative 2/3 squared is 4/9 times negative 3 is negative 4/3 plus 8/3. And just for fun, I'm going to write 6 with a denominator of 3, so that's going to be 18/3. 6 is equal to 18/3. Make the adding a little bit easier. So adding the first two, I get 4/3 plus the 18/3. So the y coordinate is 22/3, which should be up here. So that point is negative 2/3, 22/3. Coming down this way, and the y-intercept is the point 0.06. Sorry for the handwriting there, but that is 22/3 and negative 2/3 there. So the domain, once again, negative infinity to infinity, and the range is negative infinity to 22/3 with a bracket. And that is graphing quadratic functions that are written in standard form. Like I say right now, if there are x-intercepts, don't worry about finding them. A big chunk of this unit, we will talk about how to find those x-intercepts. So don't worry about that for now. Just label the vertex and the y-intercept.